The purpose of this project was to design and build a working prototype to test patio swivel chair durability. Backrest durability and chair displacement were the main focus of this project.
Here are the specifications and verifications for our project. Just name a few. Number one, the device shall be no more than 4 feet wide by 6 feet long by 7 feet high. To ensure this, the prototype will be measured using a measuring tape to verify the requirement. Number two, it is desired that the entire device should be able to move across the room. And in first, to ensure this, the prototype will be pushed around the room in a two-dimensional direction.
The backrest durability assembly uses an air cylinder and pulley system to directly pull on the backrest of a given chair where an S-shaped force sensor monitors the force being applied, making sure that when the pneumatic system is engaged, the desired amount of force is kept consistent before disengaging, causing the system to reset.
Seating durability assembly consists of two components. You have the lifting mechanism and the supporting mechanism. The supporting mechanism holds the bag. The lifting mechanism has the linear actuator, the air cylinder, and electromagnet. That system lifts the bag and then drop it.
Pneumatic components and function starts with the air compressor acting as a working fluid pressure regulator gauge, allowing to read and increase or decrease the amount of air pressure manually. Swallowing valve, which allows access to the pressurized air into the pneumatic cylinder. A meter in and meter out was added to the pneumatic cylinder to control the deceleration of the cylinder. The pneumatic cylinder, which is a single acting pole model.
Here's the Click PLC program software we use in order to have the backrest and seating test function. This is the main program which contains the subroutines for both tests. Below the two subroutines are the jog and run functions for the linear actuator in order to adjust the seating test height accordingly. Inside each subroutine program are timer loops, which allows for the time, energized, and de-energized states. Time is given for these states to cycle through, which creates a cycle count. The PLC program works in tandem with the HMI software in order to create physical buttons and settings on the screen.
This is the HMI and the main user interface. This is where we start and stop our seating durability and backrest durability tests. More information in the info screens or the info buttons. In the settings menu, we can change the cycle count, change the actuator height, set the load limit, reset the cycle count, and release the load latch when there's no load.
Shown below are the two tests, the backwards durability test and the sitting durability test. The sitting durability test simulates somebody sitting down into the chair. The backwards durability test simulates somebody reclining in the back of a chair.
Our manual breaks down the backrest and seating durability prototype along with the pneumatic system, PLC, and HMI subassemblies. This includes testing procedures, risk mitigation, and troubleshooting for each assembly.
To conclude, our team has completed the physical apparatus of both the back test and seating durability test component. The test apparatus holds its mobility and functionality as well as the compatibility for future expansion. For the plans of the remainder of the semester, the testing apparatus must cycle through 20 times in order to show satisfactory results, and to finish up final test and calibration for both tests.